Let's practice rationalizing complex rational expressions together. In other words, we're going to go ahead and rationalize imaginary denominators or make sure that there are no i's on the bottom of the fractions. For number 1, we have the expression 4 over 3i. Now the 3 on the bottom is perfectly fine, it's really just the I that we have to get rid of. So if we go ahead and multiply top and bottom by I, then on top 4 times I will be 4i, and on bottom 3i times I is going to be 3i squared. Now this I squared is really the thing that we needed to get, right? Because I squared is equal to negative 1, so we're going to rewrite this as 4i over 3 times negative 1. Now 3 times negative 1 is negative 3, so we're going to get 4i over negative 3. And then to write our final answer, let's just go ahead and put this as negative 4/3 as a coefficient and put I right next to it. So negative 4/3 I would be this final solution here, or this version would be rationalized. For number 2, we have the expression 6 over negative 4i. Let's go ahead and copy that down. And again, we like the negative 4, that's perfectly fine on bottom. The problem we have to deal with is the I on bottom. So if we go ahead and multiply top and bottom by I, then on top 6 times I will be 6i, and on bottom we're going to have negative 4 times I, which is really I squared. Now this is going to keep coming up over and over again, but I squared is equal to negative 1. So on top we're going to have 6i, and underneath we're going to have negative 4 multiplied by negative 1. So on top here we're going to have 6i over, and then negative 4 times negative 1 is going to be positive 4, so let's go ahead and put that. Then we can divide top and bottom both by their GCF of 2, so we're going to get 3/2 and then I. Okay, so this would be our rationalized version. Number 3 is a little bit more tricky just because we have 2 terms in the numerator. Let's go ahead and just write this down though. We have negative 5 plus 3i, and it's over 2i. Right? Now to rationalize this whole thing, what we're going to do is just multiply the top and bottom by I. So on top by I, bottom by I, and let's see what's going to happen if we do this. Now we're going to go ahead and distribute essentially, right? So for the top here, this I is going to go ahead and multiply by negative 5. So I times negative 5 is going to be negative 5i, and then this I multiplied by this positive 3i is going to be positive 3i squared. Now for the denominator, what's going to happen is we go ahead and multiply this I by this 2i, that's going to be 2i squared. So that's what we're going to write in the denominator, 2i squared. Okay, now we have an I squared here, we have another I squared, both of them are equal to negative 1. So we can rewrite this as negative 5i plus 3 times negative 1. Now 3 times negative 1 is negative 3, so I'm just going to go ahead and write it there. I'm going to skip that step, hopefully that's okay. And on bottom, I squared again is negative 1, but 2 times negative 1 is going to be negative 2. Okay, now just turning some stuff around here, let's go ahead and swap the numerator order. Let's say it's negative 3 minus 5i over negative 2. Okay, and then we can go ahead and separate this to write it in standard form. So that's going to be negative 3 over negative 2, which is really just positive 3 over 2. And then it's going to be a negative 5i over a negative 2, which is really plus 5 over 2i. So this right here would be our rationalized version, and it's also going to be in standard form where we have a plus or minus bi. Here's number 4. For number 4, we have a similar one, so let's go ahead and just rewrite this expression. We have 3 plus 4i, and this is all on top of negative 3i. Okay, so again, the negative 3 on bottom is fine. It's just the I we're going to deal with, so let's go ahead and multiply top and bottom by I. And in the numerator, we're going to have to distribute this I to both of these terms over here. So I times this 3 is going to be 3i. Start with that, and then take this I and multiply it by 4i. Now 4i times I, that's going to be 4i squared, so positive 4i squared. Now underneath there, let's see what we got going on. We have to multiply this I times this negative 3i. So I times negative 3i, this should be negative 3i squared. All right, so on top, notice how we do have an I squared, and on bottom we have another I squared. They're both equal to negative 1. So on the numerator, we'll have 3i, and then let's see, we have plus 4 times negative 1, which is really just minus 4. We could write plus negative 4, but I'm just going to write negative 4, or minus 4, same thing. And then on the bottom, we have negative 3 multiplied by negative 1, that's going to be positive 3. Now just rearranging the numerator so that we have the real part first. We have negative 4, which is real, plus 3i, that's the imaginary part, and this is over 3. Now just rewriting this in standard form, if we separate this into 2 different terms, we have negative 4/3, and then plus, and then, so again, this is the negative 4 over 3 that we just kind of wrote, and then we have 3i over 3. Now 3i over 3, 3 and 3 are, they can cancel out with each other, so we just get 1, so we can just write I. So we have negative 4/3, that's the A value, and then 1 would be the B value, but we don't have to write it. For number 5, we have another similar one. So we have negative 3 minus 7i, and this is on top of 4i. Okay, now what we're gonna do is let's go ahead and multiply top and bottom by I, just leave that 4 alone, and let's go ahead and take the I on top and distribute it. So I times negative 3, that's going to be negative 3i. Then take this I and multiply by negative 7i, so it's gonna be minus 7i squared. And then underneath this, let's go ahead and take this I and multiply by 4i, that'll be 4i squared. Now on top we have I squared, on bottom we have another I squared, they're both equal to negative 1. So let's go ahead and rewrite this. We have negative 3i, just leave that alone. Then negative 7 multiplied by negative 1, that would be positive 7, so this turns into a plus 7. And then underneath that we have 4 times negative 1, which is going to be negative 4. Now rearranging the top, we can write this as 7 minus 3i. Okay, just writing the real part first and then the imaginary part second. This is over negative 4. And then rewriting this in standard form, this would be negative 7/4, because a positive divided by negative is a negative. That's going to be this 7 over negative 4. And then we have a negative 3 over negative 4, which is a positive 3/4. And that would be the coefficient for I. This would be our complex number written in standard form. For number 6, we have another similar one, so hopefully it's getting a little better as we go, and you're getting the hang of it. 2 minus 5i over negative 4i. And let's go ahead and get rid of the I on bottom, and the strategy we're going to use is multiply top and bottom by I. Now on top, we're going to have to distribute the I just like in the last few examples. So let's take this I and multiply by 2. I times 2, that will be 2i. And then I multiplied by negative 5i, that's going to be minus 5i squared. And then on the bottom here, let's see, we have this I multiplied by negative 4i, that should be negative 4i squared. Notice how we have an I squared and another I squared. Those are both equal to negative 1. So we have 2i on top, and then we have minus 5 times negative 1. Now 5 times negative 1 is negative 5, but we're subtracting that, so it's really going to be plus 5. And then on bottom here, we have negative 4 multiplied by negative 1. That's going to be positive 4. Rearranging the top, we have 5 plus 2i on top of 4. And then let's go ahead and just separate this. So we have 5 over 4, and then we're going to have 2i over 4. So 5 over 4 is just 5/4, just like this. And then we have 2 over 4, that's the same thing as a half. So this is going to be 5/4 plus half an I. All right, cool. So that would be our standard form for this complex number. For number 7, we have 8i over this negative 1 plus 3i. So now for the first time, we have 2 terms on the bottom. This is where we're going to have to use something called a conjugate, right? So let's go ahead and take this 8i and put it on top of this negative 1 plus 3i. Now, if we take a look at the bottom, this is negative 1 plus 3i. Now the conjugate of that is going to be this. Let me go ahead and write it like this. I think I want to write it with a dot. And I think I wanted to go ahead and just put a fraction bar here. What I want to do is go ahead and multiply by the conjugate, which is going to be negative 1 minus 3i. And that's going to be on the bottom. And on top, we're going to have another negative 1 minus 3i. All right, so be very, very clear what's going on here, but really we have the negative 1 and negative 1 match, okay? And then we have the 3i and the 3i that match. The only difference here is that we have a plus sign over here, and then we have a minus sign over here. So this is basically using our difference of squares pattern to help us out. All right, so let's go ahead and take this 8i and distribute to negative 1. 8i times negative 1 will be negative 8i. And let's take this 8i and then multiply it by negative 3i. So 8 times negative 3, that's going to be negative 24. And then I times I is going to be I squared. Now let's see what's going on in the denominator. Well, now for the denominator, notice how a difference of squares patterns always works, but we have negative 1 times negative 1. That's going to be positive 1. So we can go ahead and write 1 over here on the bottom first. Then if we do the outers, we're going to get positive 3i. When we do the inners, we're going to get negative 3i, so they always cancel each other out, so we don't need to write it. And then when we do the last, it's going to be 3i times negative 3i, so that's going to be negative 9i squared. So let's go ahead and write minus 9i squared. Top and bottom, you're going to see two spots where we see I squared, so I squared and I squared. In the numerator, we have negative 8i, and then let's see, we have negative 24 times negative 1, so that's going to be positive 24. And then in the denominator, we have 1, and then negative 9 times negative 1 is going to be positive 9, so let's go ahead and write plus 9. Okay. Going a little further here, let's rearrange the top, so it's 24 minus 8i. Okay, just turning it around, same thing though. And then in the bottom, we have 1 plus 9 is going to be 10. And let's go ahead and turn this into standard form. So if we have 24 over 10, their GCF is 2. So divide them both by 2, and we're going to get 12 over 5. And then go ahead and see what we can divide these both by, which is going to be 2 again. So dividing those both by 2, we're going to get 4/5 I. All right, so that would be our standard form for this complex number. For number 8, we have another similar looking one, but we have a constant on top, which is kind of nice. So we have 4 over this negative 3 plus 5i. Okay, so let's just go ahead and group these first, and we're going to use the conjugate again. So let's go ahead and just multiply this by whatever is going to be completing that pattern for a difference of squares. So let's go ahead and make this negative 3 minus 5i. So again, the conjugate has to have the opposite sign of what is in the other binomial. So we had a negative 3 plus 5i, so we're writing negative 3 minus 5i. Okay, now in the numerator, let's go ahead and distribute 4 times negative 3. That's going to be negative 12. Go ahead and write that down. And then this 4 multiplied by negative 5i, that's going to be minus 20i. Now for the denominator, let's see, we're going to go ahead and use difference of squares. Let's see, negative 3 times negative 3, that's going to be positive 9. And again, the outers, if you multiply, will be positive 15i, but then we'll get negative 15i in the middle, so they'll cancel each other out. And then 5i times negative 5i squared, that's going to be negative 25i squared, so minus 25i squared. Now in the numerator, it's nice, we had a whole number, a real number of 4, so we don't have any i's up there, but the bottom we do. So on top, it's just going to stay the same for now, negative 12 minus 20i. And on the bottom, we have a 9. And then what do you have? Negative 25 times negative 1, so it's going to be positive 25. Now 9 plus 25 is 34, so we can just rewrite this as negative 12 minus 20i on top of 34. And then it looks like we can go ahead and split this into two fractions, so we can divide these both by 2, which is their GCF. So that's going to be negative 6 over 17 minus, and it looks like for these two we can divide them both by 2 as well. So that's going to be 10 over 17i. So this right here would be the standard form. For number 9, we have I showing up in a couple locations here, but no worries, we know what to do. We don't have to worry too much about the numerator right now, we just have to somehow get rid of the i's that are on the bottom. Okay, so in the bottom we do have this 4 minus 5i. We're going to go ahead and multiply by the conjugate, which is going to be 4 plus the 5i. So let's go ahead and multiply this by 4 plus 5i, the quantity of that. And as long as we do it on top, then we're not changing the value of this expression. And so on top, let's go ahead and multiply negative 3i times positive 4. That's going to be negative 12i. And then on top, we have negative 3i multiplied by positive 5i. So that's going to be negative 15i squared. Now underneath that, let's see what's going to happen here. We're going to use difference of squares again, of course. So 4 times 4 is going to be 16. That's what we're going to start with here. And then if we do the outers, that's going to be positive 20i. The inner is going to be negative 20i, so they're going to cancel each other out as usual. And then negative 5i times positive 5i is going to be negative 25i squared. Alrighty, cool. So we have I squared and I squared. These are both going to equal negative 1. So we're going to write negative 12i on top. And then instead of minus 15, it's going to be plus 15, just because we have the negative 15 times negative 1. And then underneath we have 16. And then instead of minus 25, it's going to be plus 25, just because we have negative 25 times negative 1, which is positive 25. Now on top, we're just going to turn it around, so we have the real part first. So 15 minus 12i. That's the imaginary part or the complex part of that. And then we have 16 plus 25, and I think that's going to be 41. Now 41 is a prime number, so I don't think any of the numbers on top can go with it. So separating this, we have 15 over 41 minus, and then we're going to have 12 over 41i. All right, so just like that, we have our expression, and that would be in standard form. For number 10, let's go ahead and see what we got. Okay, so we actually have some more complicated looking expressions here because we have a binomial on top, right? We have 2 minus 5i, and then underneath that we have negative 3 plus 4i. Now don't worry so much about the top right now, we have to worry about the bottom, but the top will have some extra work to do as well. But what we have to use for the conjugate is always being dictated by what's on bottom, not what's on top. Okay, so for the conjugate, let's do the bottom, which is going to be negative 3 minus 4i. Okay, same thing, just change the sign and just use the same thing on top, negative 3 minus 4i. Now, while the bottom is going to be a little bit nicer because it's a difference of squares, unfortunately the top is not. So we're going to have to deal with some more of a few more steps here. Okay, so if we want to do the top first, that's fine. Let's do 2 times negative 3. That's going to be negative 6. Okay, and then 2 times negative 4i, that's going to be negative 8i. Negative 8i. And then for the inners, we have negative 5i times negative 3. That's going to be positive 15i plus 15i. Let's go ahead and draw this a little bit longer. And then finally, we have negative 5i times negative 4i, which is going to be positive 20i squared. So plus 20i squared. On the bottom, it should be easier because of the difference of squares. So negative 3 times negative 3 is positive 9. Go ahead and write that first. And then the outers are going to cancel out with the inners. So these ones we don't have to write. But then at the end, 4i times negative 4i is going to be negative 16i squared. All right, so I'm going to do a couple things in one step right now. One thing is I would like to combine these like terms of negative 8i plus 15i. I'd also like to go ahead and turn these I squareds into negative 1. So I'm just highlighting what I'm going to do right now. So on top we have negative 6, and then negative 8i plus 15i is going to be positive 7i. And then 20 times I squared is going to be negative 20. Underneath that, we have 9 times, not 9 times, but 9 minus rather, 16 times negative 1. So it's going to be plus 16 instead because we have a negative times a negative. And then on top here, let's go ahead and combine the constants. So negative 6 and negative 20 make negative 26 plus 7i. And on bottom, 9 plus 16 is equal to 25. Now, I don't think anything has a common factor besides 1. So they're relatively prime, so we can write negative 26 over 25. And then we can write plus 7 over 25i. All right, so there would be our standard form for this complex number. All right, for number 11, we have another similar one that is a little bit more work. So let's just go ahead and start by writing it down. We have negative 3 plus 2i, that's going to be in the numerator. And then in the denominator, we have negative 2 plus 6i. Okay, so let's see what the problem is. We need to go ahead and take care of the bottom and get the i's out of there. So let's go ahead and just multiply by the conjugate of whatever the denominator is. And so on bottom, let's go ahead and say it's going to be negative 2 minus 6i. And on top, let's do another negative 2 minus 6i. Okay, so let's go ahead and multiply these out. We're going to need quite a bit of space here for the numerator. Let's go ahead and do negative 3 times negative 2. That's going to be positive 6. Then we take this negative 3 and multiply it by negative 6i. That's going to be positive 18i. So plus 18i. Then we have this 2i multiplied by negative 2. That's going to be negative 4i. And then finally 2i multiplied by negative 6i. That's going to be negative 12i squared. For the denominator, we have negative 2 times negative 2, which is going to be positive 4. The outers and the inners are going to cancel out with each other, so don't worry about that. And then 6i times negative 6i is going to be negative 36i squared. Okay, so a few things we want to do next. We have 18i minus 4i, they can be combined. I squared and I squared are both equal to negative 1. So let's go ahead and take care of those. We have 6, and then 18i minus 4i is going to be plus 14i. And then negative 12 times I squared is going to be plus 12 because we have negative 12 times negative 1. Underneath this, we have 4, and then we have negative 36 times negative 1. That's going to be positive 36. On top, 6 plus 12 is going to be 18. So we have 18 plus 14i. And then on bottom, 4 plus 36 is equal to 40. Now let's go ahead and separate this out. So we can go ahead and put 18 over 40 is the same thing as 9 over 20. And then 14 over 40 is the same thing as 7 over 20. So we have 9 over 20 plus 7 over 20i, and that would be in standard form. All right, finally for number 12, we have another one that is very similar. So let's go ahead and see if we can do this one more time and hopefully feel a little bit more confident with it as we go. So we have 4 minus 5i on top, and then we have negative 6 plus 8i on the bottom. Okay, so let's go ahead and group the top and group the bottom. And then what we can do is multiply by the conjugate. So let's go ahead and multiply top and bottom by negative 6 minus 8i and negative 6 minus 8i. On top here, if we go ahead and FOIL it out or just distribute, however you want to think about it, we're going to start with 4 times negative 6, which is negative 24. Then we're going to have 4 times negative 8i, which is negative 32i. Next, we'll have negative 5i times negative 6, which is positive 30i. Finally, we have negative 5i times negative 8i, which is going to be positive 40i squared. Just go ahead and extend that a little bit. On bottom, negative 6 times negative 6 is going to be positive 36. The outers here, along with the inners, are going to cancel each other out. And then we have 8i times negative 8i, which is going to be negative 64i squared. On top, we're going to end up combining this negative 32i plus this 30i. We're going to take care of this I squared and I squared because they're both equal to negative 1. So on top, we have negative 24, and then negative 32i plus 30i is going to be negative 2i. And then 40 times negative 1 is going to be negative 40. On the bottom here, let's see, we have 36 first, and then instead of saying minus 64, let's go ahead and write plus 64. On top, we can combine those constants, so we have negative 24 minus 40, that's going to be negative 64 minus 2i, and on bottom, we're going to end up with 100. Okay, so 64 and 100 can both divide by 4. So if you divide them both by 4, we're going to get negative 16 over 25. And then for the second fraction here, we have negative 2 over 100, which is the same thing as, let's see, it's going to be minus 1 over 50i. So this right here would be our standard form for this complex number or expression. So there you have 8 different practice problems on rationalizing some denominators and getting rid of the imaginary numbers down there. So if you found this video helpful, please consider giving it a thumbs up. And as always, keep up the great work. I'll see you in the next one.